This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode 1147, recorded on August 30th, 2024. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Austin, Texas, Rich Condit.
Hi, everybody. 91 degrees. I'm seeing mostly blue sky. Couple of puffy white clouds. 91 is good, you know, and I think we've left the hundreds behind us. As a matter of fact, they're pretty confident that we're going to get some significant rain early next week, and I'm looking forward to that.
Here it's 23C and cloudy. Also joining us from Madison, New Jersey, Brienne Barker.
Hi, great to see you all. It is 72 Fahrenheit, so about 22 Celsius here, and cloudy. And I think it will be like that for most of the weekend. Definitely doesn't feel as summery as it had.
End of August, right? That's it. Or into the September fall months next, in spirit anyway. Time goes fast, you know.
It does.
And it goes faster and faster as you get to the top of the gel.
That's right. If you liked what we do in these programs, these science programs where we try and explicate science for you, explain science, we'd love to have your support to keep them going. Microbe TV is a nonprofit entity. It's also known as a 501c3, which means anything you give us for our production is federal U.S. tax deductible. We go on your donations. If you like us, we go. We don't do ads. We don't do any kind of other support. It's all listener supported. So go to microbe.tv/contribute. I have some news items for you. There is a nice sit rep. Remember, Rich always used to talk about the sit reps during Ebola outbreak. Well, they have them for Mpox now as well. We are on situation report number 35, which is published at the beginning of August, 12th August, so it's a bit old, but gives you a nice summary of what's been going on. So this reporting period is from January 2022 through June 2024, 99,176 laboratory-confirmed cases, 208 deaths, and 116 countries, areas, territories.
These are from the WHO, right?
Yes.
These are from WHO, that's correct. And then you get some highlights, and you get some epidemiology breakdown in the different regions. It's quite interesting and useful.
So this is before the most recent outbreak in Congo of the clade 1 virus, though they have nice epidemiology curves here that show the case count by week in various months, and you can see a spike at the end of the that's Eastern Mediterranean region, not the...
No, that's African region.
Oh, it is African region.
That's African
okay.
region.
Right. So I wonder if that's the beginnings.
Yeah, at the very top where it talks about the long-term risk assessment, it talks about DRC, both linked to clade 1b and to clade 1a as being at high risk.
So the outbreak that occurred outside of Africa, went into Europe and the U.S. and many other countries, it was clade 2, is that correct?
That's correct.
And currently we have another outbreak going on in Africa, clade 1, and that went to Sweden and Thailand so far, correct?
Right. Those were single, solitary exported cases.
Right.
And clade 1 is the more pathogenic variety. Clade 2 is the less pathogenic variety. Historically, clade 1 has been associated with about a 10% mortality rate in humans, whereas clade 2 has been associated with 1% or less. And in fact, you can run the numbers. I think I ran them from this report here, and take fatalities over a case count, and it comes out to be about 0.2%.
Mm-hmm.
Okay, so it's for clade 1 significantly less than 1. I've been looking into this because, I'm supposed to be, at least by career, I'm supposed to have some knowledge of this kind of stuff. And sometimes I feel a little lame in this regard. So I want to try and make sure I'm telling things right. I've been struck by the pictures coming out of Congo, and occasionally elsewhere, of people with lesions all over them.
Mm-hmm.
Okay, which to me means that the disease in those individuals is systemic, spreading through the blood, rather than just local spread, where you would have a cluster of lesions around the site of inoculation. Mm-hmm. My understanding at this point is that that systemic spread is characteristic of the more virulent clade 1 viruses. And that's, among other things, why you're seeing that sort of pattern in the children in Congo now who are being infected with the clade 1 viruses. Whereas the clade 2, which is less pathogenic, and the systemic spread or not is probably, I would assume, as part of this, the pathogenicity, that the more systemic spread you get, the greater the risk of a bad outcome. At any rate, the clade 2 that spread globally is more clustered lesions at the site of inoculation, though I have seen what appear to be more systemic spread in that case as well. And in all cases, still, the major mode of transmission is thought to be direct contact, including sex. And as pointed out in this WHO report, the global outbreak was like 96% males and very predominantly men who have sex with men. The spread of the clade 1 virus in the Congo now is different. The
Right.
children are affected more than has been observed in the past, from what I can tell. And it's the clade 1 virus, so it shows a different sort of pattern. And my correspondence with people who do know something point out that, adults and children sleeping together is a good example of the sort of direct contact that would account for some of the spread.
Could some of that spread also happen on things like bedding?
Absolutely.
Yeah.
Direct contact fomites. What I was in particular asking about, like I said, I've had some correspondence recently. What I was in particular concerned about was whether the systemic spread in an individual could promote shedding via respiratory droplets. Because I know in the case of smallpox, which is spread as a respiratory infection, some of that comes from the fact that you have, lesions like in your mouth and your throat, and your lungs are affected as well. And so it's no surprise that you might have virus and respiratory droplets. And every time you read about monkeypox, and I think even in, some of the stuff that I've read, there will be, in describing the transmission, they'll say, well, it's direct contact. There'll always usually be, or frequently be, a note that transmission by respiratory droplet has been observed, okay, with a reference, and I've never looked up the reference. I don't know if it's the same reference every time. But apparently, from what I can tell, that is not a common mode of transmission with what's going down now, okay? But it's something that I'm interested in, shall we say. I want to keep my eye on.
It's interesting that clade 1A is mostly affecting children and 1B adults, mostly through sexual contact, right? Isn't that interesting?
Yeah. And it's, among other things, oh, actually, I have a pick at the end. That's a review by Bernie Moss on this stuff. That is, well, no, I'll preview it. Where he used an animal model to compare the pathogenicities of these various clades. And everything that I've said that comes from largely epidemiology in humans, I think, is basically verified in this animal model. It's quite interesting.
That's really cool. As I'm looking at the epidemic curves, it's a little hard to make this comparison because the y-axes are different, but it stands out to me that in the Americas, Eastern Mediterranean, and European region, the main kind of peak of infections were between June 2022 and November 2022. But in Southeast Asia and the Western Pacific, it was more between, say, April 2023 and the end of 2023. And I don't think that had I'd realized that at all until looking at these data. Is there anything to that, or this is really the first I'm kind of noticing that and looking at these data?
That was new to me too. Okay, and I have no explanation for it other than these. This spread has to do with travel and circulation in very specific communities. Once again,
Sure.
Men who have sex with men. So something about. I would think that has something to do with this, but I can't be specific. I don't know. And as you point out, the y-axes are quite different.
Yeah.
Whereas the peak in the region of the Americas is 20,000 cases. The peak in Southeast Asia is 150 cases. And then in the Western Pacific, 600 cases. So it's quite different.
Really
if you
different.
graphed them on the same scale, you would hardly even see those cases in the Southeast Asia region or the Western Pacific region.
Yeah.
All right. This is an ongoing story, obviously. We'll visit it often.
I guess my bottom line is that I'm, in particular with this outbreak in the Congo and the, increasing understanding of the difference in virulence of these things and the variants that are showing up. I'm, and my recollection of how badly we blew it at the beginning of COVID. I'm paying more attention. Okay.
All right. I found an article a couple of weeks old, but it's in the NBC News. Nassau County, New York signs first face covering ban into law. The reason I noticed this is because a kid was arrested the other day on Long Island wearing a face mask, but he had a 14-inch knife on him. He said he was going to commit a crime, so he covered his face. But, this is meant to prevent crimes of various sorts. They do say in the law shall not apply to facial coverings worn to protect the health or safety of the wearer and other things. And I just wonder, if I'm wearing a face mask on Long Island and a policeman comes up to me, I say, I want to wear a face mask to protect me against COVID. How does he know or she know?
Yeah.
Right.
I don't know how they distinguish it. So it seems, this is really disturbing, this kind of a ban. The headline, the quote underneath is, "This is not an abridgment of anybody's rights. Nobody has a right to hide their identity in public." Why not? Why not?
So Nassau County is Long Island, right?
It is. Yes, and they have cheering people where the guy is signing this bill. What's so cheery about restricting stuff that people do? I don't get it. But, many people want to wear face masks for health reasons, and this should not impinge on it whatsoever. I hope it doesn't.
Right. Maybe, maybe there are cases where they don't plan to use this unless you're involved with some other crime, and then it's sort of a thing that makes it worse.
Yeah. All right. So from what's this? Business Standard website, an article, As the world grapples with rising Mpox cases, India detects a polio case. 2-year-old child in Meghalaya confirmed to have polio, raising concerns as India was declared polio-free by WHO in 2014. So this is a case of vaccine-derived poliovirus. There's no longer, as far as we know, there isn't any wild-type poliovirus circulating in India. And the officials say, yeah, we're not worried, it's vaccine-derived, which is the wrong response. Doesn't matter if it's wild-type or vaccine-derived. It is poliovirus. It is paralitogenic. It can transmit. There is zero reason to distinguish between vaccine-derived and wild-type. This is bad. What this means is that the virus is circulating in India unbeknownst to people, and in this child, not immunized, it causes polio. The same thing happened in New York in the summer of 2022. The virus is circulating in the U.S. Nobody looks for it, so we don't know it's there. You have drops in immunization, you get polio. So
it's India still using the oral polio vaccine?
Yes, they are. They are. And you keep using it and you keep seeding with more OPV. And now many people have now realized that we should really be switching to IPV globally, which will prevent giving kids polio, because I think it's just unethical to give kids polio, whether it's directly from the vaccine or from a circulating vaccine-derived virus. But the problem with giving IPV is that you have to do it forever because it will not eliminate circulation. And, WHO sold the eradication plan to the world. Someday you'll be able to stop. And now
I don't
have to
think
change
so.
that. Nope,
No.
we're not stopping. So this is a real problem. And, it's not just India. We have now we have a case of polio in Gaza. Here's an article from the Jerusalem Post. No, maybe that's the wrong one. Oh, we did that article last year. Yeah. The article in the Jerusalem Post is all about the bad sanitation conditions, not just polio, right? We had a case of polio, which we talked about last week, but there are also other infections going on because of the poor hygienic conditions. Thousands of cases of hepatitis, diarrhea, pneumonia, scabies, lice, chickenpox, skin infections. And so, there's no organized vaccination or health care because of the conflict. So that's an article in the Jerusalem Post talking about that. Let's see, what do we have here? Eureka Alert article. More in the U.S. accept COVID-19 vaccine misinformation and willingness to vaccinate has declined. This is a report from the Annenberg Public Policy Center of the University of Pennsylvania. A quarter of Americans, 28%, believe that COVID vaccines have been responsible for thousands of deaths. This is incorrect.
A quarter.
Yeah, that's amazing.
1 in 5 Americans believe the false idea that it's safer to get an infection than to get vaccinated. And the percentage of Americans who incorrectly believe that the COVID vaccine changes people's DNA doubled to 15% from 8% in 2021.
Wow.
And this article is full of all kinds of misconceptions and benefits versus risk and so forth. So this is very scary because there's plenty of good information out there, but people are ignoring it. And the misinformation is being twisted by certain parties.
I've been thinking about this whole misinformation thing because of, there's been a lot of news lately about people who run various social platforms, whether or not they will post misinformation, whether or not they're responsible for it. And, this is going to go on forever. The only real cure ultimately to misinformation is to have a public that is capable of critical thinking. Okay. Now, misinformation is never going to go away. You need people who can ask the right questions. Okay, who know how to look at stuff, who know how to question everything.
Mm-hmm.
All right. and have some facility with how to question everything. That's the only way you're going to get rid of it is a public that's educated in the skills of critical thinking. So we'll try and do that here as best we can.
I think a little bit of it also has to do with understanding and respecting expertise.
Yes.
Because yes, I want people to question everything, but I'm not sure that I can explain every last detail of immunology to every person who questions.
Right. You do trust some experts.
Right.
You trust the history of science.
Exactly.
Okay. I'm sometimes I'm tempted to say, that I don't believe anything. I do everything empirically, but that's not true. Okay, because there's a lot of the science that I believe that I haven't done the experiments. Okay, I haven't even studied the experiments. Okay, but I know that trusted individuals have reproduced them over and over and over again. Okay,
and this doesn't just apply to COVID vaccines. There's declining flu vaccination, RSV, unsure vaccine effectiveness for HPV, pneumonia, vaccination information for pregnant people. All of this is affected. It doesn't.
One of the things that it mentions here is it says that in July 2024, less than half of those surveyed would be likely to take a combined mRNA vaccine to protect against flu, RSV, and COVID if one existed and the CDC recommended. And at the same time, 27% say they would not at all be likely to take such a vaccine. You know how amazing that vaccine would be?
Hopefully, if it would work, it has to work. Right?
Well, yes, but
I mean, that must be implicit in the question. If this vaccine worked, would you take it?
Right, exactly.
But yeah, this is just a reflection of the confusion because there's so many people spewing nonsense, and it's easy to really circulate information these days. And most of all, politicians are using it, right? They have this 2025 document and RFK Jr. and all this. People who are trying to get votes by making people scared of vaccination, telling lies, essentially. So I think this is amplifying it as well. It's very bad. And Paul Offit, who talks about this a lot on Beyond the Noise, says it's inevitable. We're going to have outbreaks of diseases that were gone, and that may change people's minds or it may not, right? All right. What else here? Okay. This is the interesting one. Science article. There's a new scientist-run virus database to be transparently run and simple to use. It's called Pathoplexus, and it is being started by a committee that has been led by Emma Hodcroft, who did a lot of, and still does, bioinformatics for many viruses, but most notably during COVID for SARS-CoV-2. And I didn't realize this, that GISAID, which is the big database, one of the big databases for virus genome sequences, the global initiative on sharing all influenza data, is run by a billionaire, Peter Bogner, who injects all kinds of politics into it.
Oh, I didn't know that.
So, I don't know if you remember at one point there was some controversy over someone using sequences from the Wuhan market to infer animals, and the guy said, you can't use it this way. He's yelling at them for using it in a way that they wanted to, which is not what you want from a database. It should be free and usable the way you want it, right? So this is a little article about that and its goals, and it's got an interview with Emma Hodcroft. And she said it's going to be run by a 5-person executive board. It's not one person in charge, as it is with Bogner. And but it's very small, right? You have to submit your sequences. Only has about 15,000, and GISAID has millions. So people have to start submitting their sequences there. This is by John Cohen, by the way, this article. I just don't understand why you would politicize a genome database, right? So,
whoever would have thought years ago that genome sequences were going to be political issue.
Indeed. Anyway, I was surprised. I didn't realize this was going. I knew there was an issue with the market sequences, but I didn't realize it was broader than that. And so I think this is a great idea.
I want to know where they got the name pathoplexus.
What does plexus mean? Let's see. Solar plexus, right? It's
right.
A plexus is get all the wrong things. A network of anastomosing or interlacing blood vessels or nerves. So it's a network of sequences of viruses, right?
Okay, yeah.
And patho that cause associated with disease, but maybe not. They don't have to be associated with disease, right?
Right.
Anyway, I'm glad to see that happening. All right, time for some science papers. And for our snippet, we have an early release from where is it from? From what is it? Emerging infectious disease.
Emerging infectious
It's
diseases.
Or is it MMW?
No, it's an early release from emerging infectious disease. And early release for people means that it's sort of not the final version, and it could be published later. Another way you can think of that is that we must have time traveled, because this is actually published in October,
right?
Which has not yet happened.
Emerging infectious diseases, right? The reason I didn't see it because I made a PDF of it so I could highlight, because the early releases don't exist as a PDF yet. And,
right. I couldn't find. I couldn't
PDF the whole page, and it took off the journal name. So, all right. So this is called Mpox Epidemiology and Vaccine Effectiveness, England 2023. So slightly older data, but I just wanted you to see what can be done from data. And this is Hannah Charles, first author, and Katie Sinka from the UK Health Security Agency in London. And so this is all about the outbreak of Mpox in England. 137 cases in 2023, and they want to estimate vaccine effectiveness. So this outbreak in the UK, remember, this is the one in 2022 that spread globally out of Africa. The peak in the UK was 2022, primarily affecting GBMSM, gay, bisexual, and men who have sex with men, and percolated into 2023. And so they looked at these cases, and they wanted to estimate the effectiveness of the modified Vaccinia Ankara Bavarian Nordic vaccine. All right? And they do this by looking at health records. So in UK, your health records are all computerized, and they can be accessed with proper permissions. So they grab all the records of people from January 1st to December 31st, 2023. It's called the UK Health Security Agency, second generation surveillance system. And a positive case is a positive monkeypox virus specific PCR. And then they also have a highly probable case. And they get test results from all over England, and they're all put into this database. The disease is notifiable. So they say it's probably a complete record of Mpox. And of course, you also get anything that the individual has reported, behavioral information, and vaccination status.
So this is on the 2023 cases.
Correct.
Numbering 137, and it's not the whole year, as opposed to the 2022 cases, which were many more.
Correct.
I kind of assumed that one of the reasons they're doing 2023 is because in 2022, the vaccination was not ramped up.
Exactly right.
Right?
That's exactly right. Yes.
Yeah, I think that's a really important point here, because a lot of this was done with this 137 set of cases. Right. And then they looked at sort of severity in those who were vaccinated versus not. So one question that I had when I was looking at this, I was really excited to read this paper and find the answer. And I realized that because of the way they did the study, I couldn't really get the answer. Is that I wondered about people who had been vaccinated previously, say because they worked in a lab or something, and if and they can't, see here if those people were protected necessarily because they're only looking at those who were the 137 positive cases.
Yeah, that's a good question. Yeah. Anyway, in this year, 2023, 137 Mpox cases. Two of them are highly probable. The rest are confirmed. Of these 137, 64 reported no travel outside the UK, probable acquisition in the UK. 58 identified as GBMSM, and 53 reported international travel. And among those, 43 are GBMSM and went to Europe, the Middle East, Asia Pacific, and North America. So most of the patients were GBMSM. 21 were adult men without information about sexual orientation and no travel to endemic countries, and they were all included as part of this. This is the clade 2B outbreak. Most of the patients were HIV negative, but most of them were also taking HIV pre-exposure prophylaxis, PrEP, right? So of these 128 HIV negative case patients, 28 reported attending an event involving sexual contact with multiple partners, and 24 had received the concurrent diagnosis of a sexually transmitted infection. So close contact, right? This is the kind of transmission scenario for Mpox. Half of the case patients with known vaccination status were either fully or partially vaccinated, greater than or equal to 1 dose, so 52 out of 106. 30 received more than 2 doses, 20 got 1 dose, and 2 didn't report the number of doses. And among the vaccinated case patients, 20 reported attending an event involving sexual contact with multiple partners. So in other words, they're vaccinated and they had an exposure, or probably had an exposure. So that's a good test of the vaccine. So between July 2022 and December 23, 77,543 GBMSM in England were vaccinated against Mpox, 32,900 1 dose, and 44,500 for 2 doses, with 2 doses. So this is the MVA Bavarian Nordic vaccine. The coverage was estimated at 37% for 1 dose, 50% for 2 doses. So what's the vaccine efficacy? 1 dose, 84%, and 2 doses, 80%, basically the same. They say less, but I think that's just basically the same given the confidence intervals. And none of the known vaccinated case patients in 2023 were hospitalized. Of the 11 persons who needed hospital treatment, 9 were unvaccinated, and the vaccination status was unknown for 2. So I'm not quite sure what VE is defined as here, frankly.
I had a little trouble with that as well.
They don't really say it. Is it rash? Is it PCR positivity? They don't say.
They reference a method, which I looked up. Let's see here.
Well, these are all PCR positive patients, so that's not the criteria that they're using. It must be disease. And then
a screening method. And if you look that up, it would be a paper all by itself, I think.
Okay.
Yeah. So in the table, they talk a little bit about the percentage of case patients with a given number of doses, and the percentage of the population who've had that many doses, matched to 14 days before onset. But I do think it certainly has to be disease, not infection, that we're looking at protection against.
Right.
And I think that we're looking at protection against disease based on that vaccine in the past, say, 1 year. Not looking at sort of longer term protection.
Yeah. So let's say 82% vaccine effectiveness. They say the vaccine probably protects against severe disease requiring hospitalization. Right. So that's 82% is pretty good. Now, this is clade 2. Rich, would you expect to see similar things with clade 1? Is it antigenically similar?
Yes.
Okay.
I would expect the vaccine to be as effective. The orthopox viruses all are serologically cross-reactive. That's one of the, and variola, vaccinia, which is the vaccine, and monkeypox are all orthopox viruses. So that's what I would expect. Yes, I've been known to be wrong.
So they conclude that during 2023 in England, there was continued low-level community transmission, and this will probably continue. And they say continued low-level transmission is likely before elimination is reached. I'm not sure that they can eliminate this. And I didn't know that it was even a plan. Any thoughts about that? I mean, you can inform people how to behave. You can give them vaccines, but there are always people who don't listen.
Oh, yeah.
Yeah.
This is going to be an ongoing problem.
Yeah.
And I don't think that people are going to, stop travel or stop things like that. So it's awfully hard to imagine. It's not going to be eradicated.
No.
And so it's hard to imagine it being completely eliminated.
So we have eradicated only one human disease.
Right.
Okay. And there were, that's smallpox. And there were important characteristics of that disease that made it eradicable. One of the most important is that there's no animal reservoir for variola. Okay. And that does not apply here. This thing probably it lives in rodents undefined at this point in Africa. So there is going to be that animal reservoir indefinitely. So there's always going to be an opportunity for spillover. There were other reasons that smallpox was eradicable as well. One being that immunization gives you lifelong immunity. Immunization or acquiring a disease gives you lifelong immunity. The other that I find just enormously interesting is that you could tell by looking at a person whether or not they'd been vaccinated or had the disease, because both the vaccination and the disease leaves you with characteristic scars.
Right.
And so that made it so that if it came to a vaccination campaign, you knew who to focus your attention on.
Right. And to tie this back to our previous discussion with polio, both the lack of lifelong immunity and the fact that people can potentially be infected and not showing symptoms, so you can't tell everyone is with the disease or with a history of disease, like Rich mentions, are a big part of the reason why those polio issues are remaining present.
Yeah.
Yeah, that was another thing you reminded me of, Brianna. So there are no asymptomatic smallpox cases that we know of.
Right. They don't contribute to transmission. There may be some, but maybe they don't contribute to it.
As long as I'm on the subject, they also developed a vaccine that could be transported, lyophilized, and reconstituted on site, and administered by people who just had a little bit of training on site.
Yeah.
Okay, it didn't require a professional, so it was just really ripe for the picking. Thank God, because it was a horrible disease, just a horrible disease. So, to me, one of the most interesting things about this paper is that 1 dose and 2 doses had the same efficacy.
Yeah.
Okay. They seem surprised by that, and they seem to even question whether they got it right. But to me, that's evidence that 1 dose is enough.
Yeah.
Which is not inconsistent with the history of immunization against pox viruses.
Yeah.
Right. So the reason why I had that question earlier is because a while ago, while working with vaccinia in the lab, I was required to be vaccinated. And so whenever I read these stories, part of me wants to know, well, is my previous vaccination protecting me? Just because it's something that I have that, most people my age do not have. And it's been more than a year. So one way that this doesn't really help me is that I don't know about longevity. But when I think back to that, I only got 1 dose.
So did you get MVA?
I think
Was it injected or scarified?
scarified.
So that's ACAM 2000.
Yeah, that is correct. But that was 1 dose. And so I guess
Yeah.
I'm a little confused why they're so surprised.
Yeah, right. Exactly. You're good, Brianne. Trust me.
Thank you.
You're okay. Though
Excellent.
CDC does recommend that people who are going to be working with pox viruses in the laboratory on a regular basis be re-immunized about every 5 years or something like that. I don't know that that's necessary. I did it. But you should have lifelong immunity from. Plus, if you're enough of a slob, you're probably boosting yourself.
So this just in. CNN reports Israel agrees to pause fighting in Gaza for polio vaccination.
That's good.
Yeah, so
Good.
this is very good. Humanitarian reasons.
It would
Maybe.
be nice if they had
Yeah.
dealt with some of the other issues that we had mentioned with some of the other infectious diseases and everything else.
So 640,000 children are going to be immunized, and apparently they're using OPV and OPV2. So, it's not ideal, but that's what they're going to do. Okay. Now, we have a paper that taught me more than I ever knew about bile acids in breast milk.
I know. I read this paper, and if I had had a chance, I would have spent some time with Steph Langle.
Yes.
As I'm sure she could have provided a lot more insight.
Actually, it's a mammoth study, and very well written. When I started out, I know nothing about any of this stuff. Well, I know a little bit about noroviruses, but when I started out, I thought I looked at the graphical abstract and I thought, this is going to be tough. But I got a little ways into it, and I kind of got the drift, and it was good.
So this is cell health and microbe. Metabolic immaturity and breast milk bile acid metabolites are central determinants of heightened newborn vulnerability to norovirus diarrhea. We have 3 co-first authors, Amy Piper, Joyce Morales Aparicio, Zhang Hu, and a senior author, a former colleague of Rich's at the University of Florida, Gainesville, Stephanie Karst, and our immune co-host, Steph Langle, is on this paper as well. We have people from UF Gainesville, UNC, Chapel Hill, University of Illinois, Case, Western Reserve, the Jesse Brown VA in Chicago, and Emory School of Medicine. So here's the summary, the executive summary. Noroviruses are small icosahedral plus strand RNA viruses constructed similar to poliovirus, a nice protein shell with a plus strand RNA inside.
Non-enveloped. Tough as nails.
Tough as nails. You just, they pass through your intestinal tract. That you eat them and they go into your intestine, they cause diarrhea, and then they're shed in copious amounts, and that's how other people get them, and they cause vomiting and diarrhea. Now, in newborns, they're more severe, so people want to know why. In this paper, they show that the metabolic immaturity of newborns and the presence of bile acids in breast milk are some reasons why newborns are more vulnerable. Now, we're talking about mice here mainly, but they do try and extend it to humans whenever they can, because there are some data in humans that are sort of congruent with what they find in mice. So the idea would be maybe you could, and they do this experimentally. They target maternal and neonatal bile acid metabolism. They can protect newborns from a norovirus disease. So you're going to learn a lot about bile acids and, what they do, and a little bit about breast milk, which we all say is great, but there's one negative here, as you will see, and it can make, at least in mice, norovirus disease worse.
Maybe in a community where there was a terrible norovirus epidemic, you could also use that to help.
That's right.
So just to bring this home for those of you who are unfamiliar with this, This is the cruise ship virus,
Mhm.
okay? And even if you've never been on a cruise, if you've stayed up all night throwing up with your kids, you've had this disease. Everybody gets this eventually. It's the most common now that rotavirus is basically suppressed with vaccination. It is the most common cause of gastroenteritis. All right, known among the cognoscente as the two-bucket disease.
Mm-hmm.
Okay. Um, I'm thinking of
And
various humorous posters
yes.
around Stephanie's lab, okay, saying no two-bucket disease here.
So there's no vaccine. I mean, there are vaccines being worked on, but we don't have one yet. We don't have antivirals. So if someone is vomiting with diarrhea, you have to keep them hydrated. And you can't just give them water, right? Because they're losing electrolytes. So you have to do like Pedialyte or something like that. And, you know, in many countries it's possible, but in many countries it's not. So babies die. There are 685 million cases a year.
Unbelievable.
50,000 to 200,000 deaths in young children every year. So this is a big problem. Now, we know that the gut microbiome is important in regulating enteric virus infections of all sorts. And in particular, so it's not just the bacteria, but it's their metabolites that do this. And that's what we're going to talk about in part in this paper. So noroviruses bind a specific metabolite called a bile acid. Okay, here we go. I don't know anything about bile acids, but I'm going to tell you what the authors say.
Well, I also think that people should be aware that that's relatively new information. You know, I think 2018 is the earliest paper they cite about that.
Yeah.
For a long time, this was something that was not really known. And there are some difficulties working with norovirus in the lab that contribute to that. And so you can also realize that we're just now figuring out what to do about this two-bucket disease.
Yeah, as a matter of fact, let me elaborate a little bit on this model. Brianne triggered this. You cannot grow the human virus in the laboratory. What we know about the human virus and its infection was learned by infecting volunteers with the virus. So this mouse model is not, it's cool in that it's not like ordinarily when we talk about mouse models, we're talking about taking a human virus or a virus from some other animal and sticking it in a mouse. No, this is a mouse norovirus. So it's what I would call well, I don't know what to call it, but it's the host and the virus are, it's a natural virus of this host, of mice, okay? Sometimes this gets a little pushback because there are some differences between, or some people talk of differences between the disease in mice and the human disease, but there are a number of different strains, and they focus on a strain here that I think is very closely mimics the human disease.
Right. So we're talking about murine norovirus here.
Yes,
right.
Mouse norovirus.
The mouse. So, all right. So they bind bile acids. So let's talk a little bit about bile acids. They're made in the liver from cholesterol, and then they're joined to either taurine or glycine, and then we call them conjugated primary bile acids. They're stored in the gallbladder, which many of you have lost years ago, right? And then when you eat, the bile acids come out of your gallbladder into the duodenum to help with digestion.
In particular, help with digestion with fatty stuff.
Fatty stuff,
which
right.
is why if you lost your gallbladder and you go out and have a Big Mac, you might have trouble shortly down the road.
Right. So once the bile acids, these conjugated primary bile acids get into the intestinal lumen, the bacteria there, your microbiome, metabolize them into unconjugated primary and secondary bile acids, and they make what are called microbial conjugated bile acids. And these are reabsorbed, but most of these are reabsorbed across the intestinal epithelium and go back to the liver. Something sounds familiar. You're going to recycle them, right? And this is called the enterohepatic circulation. They go back in the liver, and then, of course, they're going to be reconjugated to taurine or glycine and stored in the gallbladder. So it's recycled, right? And this transport is mediated by a transporter in the intestine. It's called the apical sodium-dependent bile acid transporter. That's going to play a role in this story as well.
The paper is open access, and the graphical abstract, once you sort of get a little bit of a grip on this, is quite good.
Yes.
I found myself referring back to it all the time to make sure I was still on the right road.
Yes. So the idea is that these bile acids are made by the liver, help us with digestion. However, the microbes in our GI tract can change them, but
Right.
we can recycle them and change them back.
Right.
Now, it's been shown that interaction with conjugated bile acids is proviral. It helps virus replication for both human and murine noroviruses in vitro in cultured cells. And there are a number of mechanisms, but certain bile acids can inhibit infection in an interferon-dependent manner. So that's one of the mechanisms of the other effect. And this process seems to occur for different viruses, and so it's maybe a general principle. So conjugated bile acids promote norovirus infection, and the ones that are generated by microbes, the ones that they deconjugate, they activate an antiviral response and inhibit infection. One mechanism may be interferon, and this can determine susceptibility. Okay, so that's bile acids, conjugated and unconjugated, right? And their effect. So conjugated bile acids help noroviruses, and unconjugated do not. Okay, now the other important part here is that bile acids are different in neonates and adults. First of all, the genes are regulated. They're off or low at birth, and then they go up. The bacteria are not all there at the beginning, right? They're low at birth. They steadily increase. Enterohepatic cycling, right? The cycling of bile acids is diminished in neonates and goes up with adults. It's all about the transporter, ABST. And here's the kicker. Breastfed neonates get maternal bile acids, and the maternal bile acids are conjugated. And remember, the conjugated bile acids can potentiate virus infection. So you have host bile acids, which potentiate virus replication, and you have microbial that modulate it. This is an interesting little push-pull here that's going on, right? And so they're going to study that here. And this is the summary. The two different kinds of bile acids have two different effects, and maternal bile acids delivered to the neonate govern vulnerability to murine norovirus diarrhea. Okay, we're going to see a bunch of really cool experiments that address that. Okay, so they have this mouse model that Rich and Brianne have told you a bit about. Neonatal mice, if you infect them with murine norovirus, they get a self-resolving diarrhea that kind of mirrors norovirus disease. They don't throw up because mice don't vomit, and but they do have diarrhea. So they can test the role of the gut microbiota. They give mice a couple of doses of antibiotics that wipe out their intestinal microbiota. And they've picked a cocktail of the 3 antibiotics most commonly given to human neonates. Then they wipe out their microbiota, and then they infect them with a strain of murine norovirus. It's called diarrheagenic. I think you can guess what that means. And they find when they deplete the microbiota, you exacerbate virus-induced diarrhea, right? The other thing you can do is measure permeability. Diarrhea is associated with increased permeability of the epithelial barrier, and you can give mice a labeled dextran, a compound that you can measure getting into the circulation, and you can see that antibiotic treatment followed by norovirus infection increases the permeability of the epithelial barrier. And they do those two assessments throughout, diarrhea and the uptake of this dye. Now, interestingly, they look to see whether this increased diarrhea is associated with increased virus titers, right? Because you might think it would. So they measure infectivity, but they only see a twofold increase in titers in the antibiotic-treated animals. So they, for various reasons that we don't need to go into, they don't think that their infectivity assay is a good assessment of virus replication. So they look for infected cells instead in the intestine. And they find twice as many cells that are infected when you treat mice with antibiotics. So it's all consistent with this idea that the microbiota is providing protection against diarrhea caused by this strain of norovirus, right?
Yep.
The idea from that is the virus load or virus replication is, by some criteria at least, higher when you've wiped out the microbiome. So one of the one of the discussions we're having here is that in the neonatal mice, the microbiome does not do as much as in adults in processing the bile acids to give you appropriate protection. However, this shows you that it's doing something.
Yeah,
yes.
Okay. That's right. It's a good point. So we know that antibiotic depletion changes the bile acid pool. That's already been known. So they say, let's add back to these antibiotic-treated mice a bacterium that will reconstitute bile acids, basically. It has bile acid, what they call biotransforming activity that will and it rescues the antibiotic-mediated increase in diarrhea.
Yeah, so they knew that the microbiome somehow was helping to protect or helping to ameliorate the disease, and they said we assume that is through bile acids. So now we're going to test to see if just sort of changing the bile acid production in the microbiome changes the phenotype.
Now, they think that the key issue here is the removal of the taurine or the glycine from the conjugated bile acids, right? So they do an experiment to look at this. This is just another, they're all very beautiful experiments. This one, they treat mice with antibiotics, and then they give them caffeic acid phenylethyl ester, or AA10. These are inhibitors of the bacterial enzyme that's responsible for bioconjugation. Isn't that brilliant? Inhibitors, all right, after they reconstitute with the Clostridium. And these drugs abolish the protective effect of adding Clostridium back, which would give you your deconjugated, right? So you're inhibiting deconjugation of the bile acids. So it shows you that taurine glycine that's removed by the microbiome is important. I love that. It's a cool experiment. Okay, so let's next say, what is the role of bile acids made by microbiome in protection? So they have an unconjugated secondary bile acid called deoxycholic acid, and this is known to reduce viral titers in adult mice. And so you take antibiotic-treated mice, you treat them with DCA. This fully rescues protection from disease afforded by the gut microbiota. So you take away the protection by antibiotics, but if you add DCA back, it restores all the protection, right? It's because it's an unconjugated bile acid. Basically, you're adding back what the bacteria can't make because you've treated them with antibiotics, right?
Right. So it seems like the unconjugated bile acid is helpful. The ones that the host normally makes that is conjugated is exacerbating the disease.
So this is useful. This could be useful, right? Because this would be a treatment, right? And somehow you have a particular bile acid or an analog of it that could be potentially an antiviral. So they want to know the mechanism. And so they do some experiments to address that. We know that there is a G protein coupled bile acid receptor, which inhibits the replication of numerous viruses. So they wondered if it functions against norovirus. And then again, if they treat mice with an agonist of this receptor called int777 for 3 days, it protects against virus-induced disease. So it looks like it's binding to this receptor that's mediating the protection. They take mice that lack this bile acid receptor, TGR5 null mice, and in those mice, the protection doesn't work anymore. So apparently the bile acid has to bind to that receptor in order to get protection against norovirus infection. Interestingly, they find that interferon beta induction goes up in the small intestines of infected mice that are pretreated with this INT777, this agonist of the receptor. And it's dependent also on, the interferon effect is dependent on TGR5. So they think, and there's a role for type 1 interferon, but not type 3 in protecting from norovirus-induced diarrhea, which is coupled to this bile acid effect. So basically, the bile acids are binding TGR5 receptor and maybe driving in it the type 1 interferon response and other things as well to prevent disease. It's really cool. Very interesting. Okay, so that is the interplay between the bile acids and the microbiome. So then they want to look at the age-dependent susceptibility. Why are neonates so more susceptible to severe diarrhea? So this has never been done before. Apparently, they do mass spectrometry to look at the bile acids in neonatal and adult mice feces. They quantified 46 different kinds of bile acids. Did you know you had 46 different kinds of bile acids in your gut? I didn't know that. And neonates excrete less total bile acids than adults. Adults mainly excrete unconjugated microbiota metabolized bile acids. Neonates excrete mostly conjugated bile acids. So you can already guess what that would all do, right? The conjugated are the ones that are potentiating disease.
And the differences are striking.
Yes.
They are.
And
Yes.
this has to do, as Vincent outlined in the introduction, has to do with, in the neonates, the immaturity of the gut microbiota, which will process the conjugated bile acids. And it also has to do with the immaturity of the genes that metabolize, the mouse genes that metabolize the bile acids as well. So you have lower total amount of bile acid and higher unprocessed.
So the most abundant bile acid in neonatal feces is TCA, taurocholic acid. So they say, let's give mice some TCA, neonatal mice, and see what happens. And in fact, if you supplement, you give mice TCA, it makes the virus-induced disease worse, whether you have bacteria there or not, because that's one of these adult bile acids that is promoting virus replication. I have another one, another conjugated acid, glycoquinodeoxycholic acid, which also promotes virus pathogenesis in their mouse model. So all of these experiments show that host bile acids exacerbate norovirus disease. They're the dominant class in neonatal hosts, and they say this is where this metabolic immaturity comes from, because they are not metabolized by the microbiome. So they say that the metabolic immaturity of neonates makes them more susceptible to norovirus infection.
And by the way, we've already done and talked about the converse experiment, where you give them the adult unconjugated bile acid DCA, and that restores the resistance to norovirus, even in antibiotic-treated mouse.
Now we turn to breast milk because in 1983, it was discovered that there are bile acids in breast milk. So how would that contribute to norovirus disease? So they collect breast milk from lactating dams. They quantify the 79 different bile acid species as we did before. TCA, remember TCA? Taurocholic acid, is that the right? Yes, taurocholic acid is the most abundant bile acid in breast milk, but there are other species as well. So they decide to test whether these breast milk bile acids influence susceptibility. And so they have a little bit of a different model here. Remember the enterohepatic circulation, right? They go from the gallbladder into the small intestine. They're deconjugated, then they go back into the liver by the enterohepatic circulation. So they say since there were microbiota-dependent bile acids in breast milk, they must have come from the gut, right? And trafficked to the mammary gland. And if you remember from the beginning of the paper, this transporter ASBT, it's the major intestinal uptake mechanism for bile acids. So they take mice lacking the gene for that and predict that, if the bile acids can't get to the breast milk, we're going to see an effect. In fact, that's what they see, a 50% reduction in total bile acids in breast milk from these mice lacking the bile acid transporter. So you have a reduced amount of conjugated bile acids there. They infect these knockout mice with norovirus. They look for diarrhea. They're fully protected from norovirus-induced diarrhea by not having this transporter that picks up the unconjugated bile acids in the gut and brings them to the mammary gland. Isn't that amazing?
Yeah.
Amazing.
Actually, it's not unconjugated. It's conjugated, right? Not unconjugated.
Yeah, they're moving the conjugated bile acid. So it seems like the mom is giving the pup conjugated bile acid in breast milk, whether that's evolved on purpose for a reason or not. We cannot say. Perhaps it's helping the newborn digest. Perhaps it's a weird byproduct of receptor expression. But that conjugated bile acid that mom is providing is actually potentially making the norovirus diarrhea worse.
So do I have this right? ABST will transport both conjugated and unconjugated, right?
I think it transports both, but only the adult has much conjugated to be transported.
But in the adult, in the intestine, the bacteria deconjugate the bile acid that gets transported to the liver. So there must be both can be transported. But the key here is that you're taking away the conjugated ones by removing you're taking everything away, and that decreases diarrhea. It's very cool. Completely protected by removing this transporter. And they go through some experiments to show that it's not. So the pup has its own ASBT gene, which is off or low, and they do some experiments to show that it's not turned on, which would be mediating this effect, and that's quite clear. Okay, so can maternal bile acids given to pups potentiate virus replication? So they have ASBT null pups, so the pups do not have the transporter. They're nursed by wild-type dams, so the breast milk that they're getting has a normal bile compositions, but the pups themselves can't absorb it because they don't have the transporter. 64% of these pups get diarrhea compared to 63% fostered with a wild-type dam. Okay, so that shows you that I've lost my track. What does it show you? ABST null pups. So you can't. They develop as much diarrhea as wild-type pups fostered from a wild-type dam. Right. So the bile acids being delivered by the mom is causing the diarrhea, and it's the same as in a normal matchup And in the converse, 14% of wild-type pups, 6% of the knockout pups nursed by knockout dams develop diarrhea. And another experiment they did, they treat dams with cholestyramine, which is a oral bile acid sequestering agent. It binds up bile acids. It just basically depletes the bile acid pool. They see that there's a 50% reduction in breast milk bile acids, and the severity and incidence of diarrhea inversely correlates with the concentration of cholestyramine, right? So if you bind up the bile acids with cholestyramine, you have less severe disease. They also wonder if there's an interplay between bile acid metabolism and B cell responses. And remember, we did this paper on backflow of viruses from pups to dams.
Yes.
And they say this could be immunogenic to the mother. Maybe the mother's making antibodies, and that's part of it, but they don't see any antibodies and no IgA in breast milk. And so they think it's really the bile acids that are doing the role here. So they have an experiment where they take ASBT null pups nursed by ASBT null dams. So neither can absorb bile acids. They give them TCA, this abundant bile acid in breast milk, and that by itself is enough to promote pathogenesis. Okay, so if you give them this conjugated bile acid, and both the mother and the pup cannot absorb any bile acid, that's enough to promote the pathogenesis of norovirus. So reduced delivery of conjugated bile acids in breast milk is responsible for protecting neonates. So in other words, the conjugated bile acids given to the neonates in breast milk make their diarrhea worse.
I think it's actually more the unconjugated ones make the diarrhea worse, because the neonate is doing some conjugation themselves. They just don't have the microbes to unconjugate.
Right, it's the conjugated ones. Yes.
Yeah.
And that's what's reduced in these ABST null dams, right? And they say that in humans, conjugated bile acids enhance infection in vitro. So there's a little connection there. Infants are susceptible to human norovirus, severe norovirus infection. So they say, it could be that this is also applying to people. And they notice that half of the bile acid pool in human breast milk is composed of conjugated species like it is in mouse breast milk. So they're doesn't prove it, but they're hoping that it's a similar situation in people so that we could make some kind of interventions. The last paragraph, they say, you should still breastfeed your kids. It's good. There are other good things that come from that, right? They protect, maternal bile acids from breastfeeding, protect intestines. And so they actually do an experiment here showing that the breast milk from a dam to the pup does protect against an artificially induced injury. So, there are lots of positive effects of breast milk. So you shouldn't stop feeding, doing breast milk feeding. But somehow the virus has adapted to be able to use these conjugated bile acids to promote their replication, which is independent of what the host needs to do with its breast milk.
So I can hear the conversations going on. So, oh no, if we publish this, the wackos are going to get a hold of this.
That's right. That's right.
And tell everybody not to breastfeed because it's terrible. Okay.
Well, so I kind of wonder if that interferon beta part of this isn't particularly important.
Yeah.
It's sort of like in the adult, we are making these unconjugated bile acids because of the microbes.
Right.
And that's turning on interferon.
Yep.
And potentially that interferon is getting rid of some of the virus.
Right.
And making sure there's no diarrhea. In the baby, we're delivering bile acids that don't have this interferon producing effect. the babies don't have the microbes to make this interferon producing effect.
I see what you mean.
And so the babies aren't making the interferon and
I
thus
see what
can't
you-
protect against the virus.
Yeah.
Okay.
And so my thought is, you know, in a perfect world, could you have a probiotic that did the conversion and allowed the baby to start making some of that interferon
Yes.
and
Yes.
gave them the protection?
Yeah, and it's a matter the other approach, which they allude to at least in their discussion, is to somehow supply the unconjugated bile acid
Right. Right.
Mhm.
as, say, a dietary supplement or something like that. But in a way, a probiotic makes more sense because it's sort of
Yeah.
with you.
Yeah.
I wonder if, I mean, is it the case that all neonates are susceptible to enhanced disease, or is it a fraction? And maybe some kids have the right microbiome.
I bet you it's a lot more complicated
Yeah.
than just this, right?
I bet you it's a fraction based on things like how much bile acid
Yeah.
mom has in breast milk. Probably, of course, involves what the kid's microbiome is and whether or not the kid is breastfed. I was sort of wondering. I kind of had a little diversion in my thinking as we were going through this about how this would look in mice that weren't in the lab.
Yeah.
With more sort of native microbiome.
Yeah, we have inbred strains, and we have inbred strains of mice, and we probably, Stephanie, if you're listening, you can write us an email on this. We're probably focused on a strain of virus that gives a measurable disease. Okay,
Right.
So we have essentially inbred strain of virus as well. So
yeah. Well, I guess
there
I was
could
kind
be-
of thinking the mice might be, and this is from another immunology paper I love. The mice might be, cleaner or less dirty in their microbiome
Mhm.
than wild mice, and so
Mhm.
does that change how much bile acid conversion we see in
Yeah.
the real world, and how is that variation in us outbred, not clean microbes humans?
Yeah. So basically, the conjugated bile acids, which the babies have a lot of because they don't have a microbiome that can remove the conjugation, they don't have the right transporter, they promote infection, and adult conjugated inhibit. But they also find that bile acids delivered in breast milk play a role because the mother is delivering conjugated bile acids, and that potentiates disease as well. They make a nice statement here. I love this. While our findings may seem to contradict the well-established role of breastfeeding in protecting newborns, it's important to note there's no strong evidence for an association between breastfeeding and protection from norovirus-induced diarrhea in infants. They go on to cite good evidence for other viruses that breast milk is good, but not for norovirus, and this could be why, right?
Right.
This is not meant to minimize the undeniable health benefits of breastfeeding. I think Steph and Stephanie both wrote that, right?
Yeah.
But instead, to underscore the factor that factors influencing norovirus disease severity in neonates remain poorly defined and are undoubtedly multifactorial. So they say we should develop infant-specific therapeutic strategies based on these findings, maybe targeting activating receptors like TGR5 that potentiate antiviral immune responses. The trafficking might be targeting. This is very, very interesting. You can imagine many different ways that you could approach therapeutics from this knowledge. So I like this a lot. Cool paper, folks. You like this? It's good?
Very, very
Yeah,
cool paper.
good. Very cool.
Good job, Steph and Stephanie,
Yeah.
all.
Good job.
Let's do a couple of emails here. Rich, can you take that first one?
Maria writes, TWiV team, it's always a pleasure to have an episode with Jolene, and this was no exception. Macrophages are cool and not created in a lab. I thought your approach to addressing Alina Chan's article was really good. I found myself raging at the op-ed and how it very subtly makes the case for something nefarious going on, while appearing to suggest all she thinks is that there was an accident. Commentators on the article suggested that the Wuhan lab has deliberately hidden any information about the alleged virus because, duh. But then that means that it was a deliberate leak. If it was a deliberate leak, then why would it matter if they had lax BSL-2 conditions? That would only be relevant for an accidental leak. But if your accusations are vague enough, then everything proves your point, because the point is different each time for each reader. That said, I wish you had addressed a bit more of the personal stuff more than the science. Not because I care myself, but because I suspect it's what people will continue to hold on to. I'm sure you didn't address it because it feels like irrelevant gossip to you, but to draw the parallel with climate research further, I seem to recall that emails among researchers were also used to great effect to discredit climate change research. I'll bet Alan knows exactly what I'm talking about. He always does. I'm sure Dr. Chan's own emails would not survive quoting out of text, but the one exchange between Dr. Barrick and Dr. Daszak that she cited, which comes from a much more balanced Vanity Fair article on Dr. Barrick's testimony before Congress, and she gives a link to that, is interesting and I think will capture people's imagination. It appears from the Vanity Fair article that Dr. Barrick does not believe that the virus spillover happened at the market. At some point, his testimony will likely become fully public, so I think if you could address his thoughts more directly, it would be great. Dr. Chan's conspiracy thinking is clearly misguided, but Dr. Barrick's position feels like he's pointing to a real scientific question. Was some version of SARS-CoV-2 circulating in October 2019? How would we know? Probably ought to look at that testimony to Congress and see what that was, get more detail about that. So my request, should you choose to accept it, is whether you could address this a bit further. I assume bringing Dr. Barrick again on the show is out of the question, but perhaps you can figure out some middle ground. That said, I'm going through the 2020-2022 catalog, and my question may yet be answered. I'm a latecomer to TWiV. I'll say that when this thing blows over, it might be nice to have a similar evidence review episode on everything we have learned in the last 4 years. How is it 4 years already?
Mm-hmm.
As in, if someone were drafting a textbook article on SARS-CoV-2 virus and COVID-19, what would they write? Maybe I should just tune into Vincent's lecture, but I'm unfortunately too busy. I just get to listen during runs and commutes. Thanks so much for everything you do. I've sent really short emails before because I only ever get a chance to work on them on my phone, but I tried to share a high-effort email this time, even though it's still on my phone, so apologize for the typing and bad formatting. Best, Maria. Yeah, so I'm interested in...
I'm skimming the Vanity Fair article now.
So first of all, I don't know what personal stuff she means, but I don't think that's relevant.
I think she's talking about emails among investigators and that kind of stuff, because she refers to the exchange between Barrick and Daszak.
Yeah, I don't think they mean anything. They're musings of scientists, which can change, right? And it's the way it's supposed to be. Now, the Barrick opinion, there is no circulation in October 2019. All the molecular clocks say late November, early December, very clearly. And I think he probably said this before, those sequences from the market that clearly showed two different spillovers there, right? Two different lineages. His idea was it spilled over somewhere else in the market as an amplifier. But
that is hard to tell from this article.
What's it?
So the article date is May 1st, 2024.
Mm-hmm.
They say that this testimony was on January 22nd of this year, which they have exclusively reviewed.
Okay.
So we cannot see if they're, I cannot verify these quotes. But
There is, yeah. I mean,
but there is a quote in here where he says the genomic evidence suggests that COVID-19 was already circulating in the human population by mid to late October. Clearly, the market was a conduit for expansion, he testified. Is that where it started? I don't think so.
Yeah, that's not correct. I think that's wrong. I know that Ralph is an expert, and that's why this is heavy that he says this, but that's not correct. I've spoken to many other genomicists who say it's not correct. And the preponderance of evidence indicates that it was the spillover site. So I just think this is one case where he can have his opinion, but it's not supported by most of the evidence.
Yeah, I would need to see some evidence before.
Yeah. Before
being sure what he said here.
There's no isolate before December, right? There's just nothing, and the clock calculations don't support an October circulation. So
yeah, I wonder how out of context those comments are.
Yeah. Okay, can you take the next one, Brianne?
Sure. Vincent and team, thanks for the recent podcast discussing Alina Chan's opinion piece in the New York Times. Having read that article and being a listener to the This Week In catalog, my initial thought, as always, was where is the evidence? I didn't see any, and it seems like you didn't either. One of the references in Alina Chan's article is to this article about Ralph Baric, and they link the same Vanity Fair article we just mentioned. Baric told congressional investigators that he believes it's far more likely that SARS-CoV-2 spilled over naturally from animals to humans, given the sheer abundance of viruses in nature. But he also said in his testimony that he disagrees with the most widely promulgated spillover argument, that the virus leapt from infected animals to people at the Hunan seafood wholesale market where it first burst into public view in December 2019. The argument does not hold up, he said, because genomic evidence suggests that COVID-19 was already circulating in the human population by mid to late October. Clearly, the market was a conduit for expansion, he testified. Is that where it started? I don't think so. My question for the TWiVers is, what is Baric referencing or relying on to get the mid to late October date? Thanks, and thanks for all you do. Dave, that is my question too.
It's a paper that was published that said the clock pushes it back to October, which many people have said is flawed. And, I was involved in a bunch of this discussion not too long ago, and everything that we have about the markets is consistent with a market spillover. There's nothing consistent with a spillover anywhere else, except potentially it being around in October, and it's just not right.
Right. Well, and I would also be interested in seeing the full testimony to see how in or out of context that sentence is.
Yeah, it's available. You can get it.
The whole thing is now?
Yeah, the whole thing's available. Okay. Yeah. Okay, Don writes, came across this article over a year ago and would very much appreciate hearing the thoughts on this from the experts at TWiV. All right, so this is an article here. Timeline of SARS-CoV-2 spread in Italy results from an independent serological investigation. And they, all right, let me read his letter. First, do you think the methods used in analysis were sound? Are the author's assertion within the discussion reasonable? If so, that could indicate SARS-CoV-2 had occurred in Italy 2 to 3 months before the earliest official cases in Wuhan. Okay, I'm not going to read any more. This is contamination in the Italian lab, okay? There's no question about it. The virus was not circulating 2 to 3 months earlier in Italy than in Wuhan. If you do PCR and you've got viral DNA around, you're going to contaminate your PCR, and that's exactly what happened there. It was like a later variant that wasn't even circulating.
It also looks like they're looking at antibodies here.
Yeah, and there's probably some cross-reactive things going on, right? Which we know. Okay, so it's contamination. Let's go back to Rich.
John writes, with that protein arginine methyltransferase, well, maybe it'll come. I'm blanking on what we were talking about.
Were you on the episode with the rice?
Yes, I was.
The rice virus and the
right.
The saliva.
Right. Oh my God. I correctly guessed why protein was in the name before you hit on it as well. Right. It's an arginine methyltransferase. It transfers methyl groups from arginine to protein.
No, it's to arginines that are already in proteins, not
to
free
arginines.
arginines.
Yes. Okay. Fine. Protein arginine. Yes. But significant word economy could be achieved by simply calling it arginyl methyltransferase.
Yeah, that's true.
Arginyl, by definition, means an arginine residue, arginine, the peptide linkage, in a protein. Merriam-Webster even has it as a noun for anyone who might raise that issue. Otherwise, orchestras warm up, don't they? And baseball players throw the ball around before the game. So weather, etc., before driving in on viruses is the same thing.
Warming up. That's right. We're warming up.
Okay. So I didn't realize that way he had morphed from arginyl to the weather.
Yeah, right.
Okay. Cheers from a partly cloudy Greater Braddock, site of the 1755 Battle of Braddock's Field and home of John Fetterman, where humidity that Ernesto had bottled up has finally departed, since he has finally left Bermuda alone and is now off in search of Newfoundland. As a result, here it is now partly cloudy and 16C headed for 22, which should repeat itself tomorrow and Wednesday. Cheers, John.
Mm-hmm.
Okay. Arginyl methyltransferase. John, you got the whole thing. You got pedantry. Okay. You got trivia. You got weather. You're totally clued in. Thank you.
Brianne.
Charles writes, "Hello, Twivers. It is a damn hot day in Chapel Hill, North Carolina." I remember those. 93 Fahrenheit, 34C after a very nice weekend. Derek Lowe has a good commentary about RFK Jr., a person I consider a mass murderer that uses words to kill. Too bad he will not be held accountable for his actions. His actions were at least as bad as yelling fire in a crowded theater, but may not meet the imminent lawless action standard, though clearly meeting the clear and present danger standard. There is a tiny bit of hope in Michelle Carter's involuntary manslaughter conviction was for talking her boyfriend into committing suicide. And Charles gives a link to the cases that he's talking about here.
There's a really nice article by Derek Lowe about all this anti-vaccine propaganda. Lowe is a good writer. Usually writes about drug development, but he used to write a column. Yeah, well, it still does. It's called In the Pipeline, and gives a little bit of a history of RFK Jr. He said this is important now because he's endorsed Trump, right? So he may have an in. This is a very interesting way to put it. A person I consider a mass murderer that uses words to kill.
Yeah.
Anthony writes, 10 years or so ago at the New Jersey State Park in Fort Lee at the top of the Palisades, adjacent to the George Washington Bridge, I saw deer coming out of the woods at dusk. They proceeded to the parking area and investigated, and then ate from trash containers. If now there were face masks there, the deer would be sure to encounter that. I'd guess that saliva and sweat-tinged fabric would be seen as a food item by a deer. In the Jersey City Heights, certainly from at least the very early 60s until the early 90s, there were no raccoons, opossums, or skunks. Now these animals are frequently encountered. I tend to guess that displaced populations did not move up from Secaucus, where there was development in the 80s. My guess is that as long as they could, wild animal populations receded away from human contact. Once they could retreat no more, individuals tolerant of living with people were what survived. Now, with that ability, wildlife could turn the tide and flow back into urban areas that they'd left hundreds of years before. Not a theory, not a hypothesis, a guess. On a separate note, I'd seen many years ago the small piles of mussel shells and crayfish exoskeletons on the banks of the Delaware from raccoons feeding on what their fingertips told them was under rocks. I find amazing that the raccoons in the Jersey City Heights, never having hunted in an aquatic environment, will, on a fire escape, investigate a dish of water. Because all this is inspired by our SARS-CoV-2 in wildlife episode, right? Which, by the way, we called it let's see, SARS-CoV-2 gone wild with a side of rice, remember?
Right.
Mm-hmm.
It was released on Sunday. It's got 30,000 views on YouTube, which is unheard of almost in less than a week. I don't know what's tickling people about that.
Have you used SARS-CoV-2 in a title recently? Or maybe it's the
Maybe.
SARS-CoV-2 in wildlife caught people's attention.
Maybe. But yeah, I don't know that we often use SARS-CoV-2 because we always have to do clever stuff, you know. So.
Right.
But it's an endorsement for being straightforward, you know.
Mm-hmm.
Yeah.
Okay, let's do some picks of the week. We have lots of email. We'll get to them next time. Brianne, what do you have for us?
So I have an article. I actually came across it on a different website, but it was paywalled. And they have the same article here that was published this week about a study that came out in Nature Geoscience. Not one that I frequently read. But in this study, the authors had looked at a number of ice cores to look at past ecosystems. And specifically, as they went through those ice cores, they looked at viruses and how viral composition had changed over time. They did this during doing a metagenomic analysis, basically looking at how viruses changed and kind of trying to correlate that with climate over the past 41,000 years. One of the things that was pretty cool is that they found 1,705 virus species, which they say expands the known glacier-preserved ancient virus number by 50 times. And only a quarter of the viruses that they found had similarities to previously found viruses. So lots of novel viruses here. Some of those that were known were viruses that have been found in that same geographic location more recently, while others are only found in other places. So it kind of gives you some idea for travel. And they were able to start to look at find different groups of viruses that predominated during kind of warm or hot cycles. My guess on that is that is probably related to hosts that were able to be present during those. They look a little bit at some of the bacteria that were there that may be phage hosts. But I thought it was pretty cool that these geologists decided that one of the ways that would be interesting to them to think about how organisms and how life has adapted to different temperatures would in fact be by looking at viral compositions. Usually if I see an article that says viruses and climate change, I think about maybe changes in hosts or vectors or things like that. I don't actually think about whether there are going to be changes in what genes are frequently found in viruses or other adaptations, which they at least suggest here, that different types of genes seem to be found based on things like horizontal gene transfer during some of those different periods of time. And so the article that I have as a pick is from the authors of this study. The geologists themselves wrote kind of their take on what they had seen on a website called The Conversation.
So are these mostly phage? Do you know?
I think it was, I see it as mostly phage, yes.
Okay. Cool.
This is a cool article, too.
Yeah.
The original article is worth reading.
Yeah, I thought it was really cool. And I also always love sort of the big eye-popping numbers of, oh, we did this study and look how many new viruses we found. And what that tells us about how much of the virus sphere there still is to discover.
Yeah, neat. Rich, what do you have for us?
So I have a review written by Bernie Moss on monkeypox. So this is really straightforward, just plain old science. But we've been talking a lot about monkeypox. This is, the recent outbreak in Congo of clade 1 viruses in children is quite recent, and this predates that. Okay. But it's a really nice summary of everything that we've been talking about monkeypox. It gives a history, the timeline, distribution, life cycle, characteristics of clade 1, clade 2, what the different animal models are, what the phenotypes of the disease are in the animals. And I haven't read it in detail, but knowing Bernie, I'm sure it's quite readable and quite complete.
This looks amazing.
Yeah.
This looks great.
As soon as you put this here, I downloaded it immediately. I was very excited to read it.
Yeah, because I've had a bunch of questions running around in my mind, and I wrote Bernie with a couple of my questions, and he answered my questions and sent me this.
This is great. This is just great. Everything you wanted to know. It even got a replication cycle.
Yep. The whole
love
thing.
it. I wonder if they just knocked this off in a day or two.
Sure. Yeah.
He knows it all, right?
He knows it all.
It's very cool.
He's encyclopedic.
Nice. All right.
I think I mentioned
Yep.
at the top of the show, too. This is, in my mind, coupled with a paper where he uses a specific strain of mice to compare the pathogenicity of the different clades of virus. And my guess is that those results are summarized in this as well. It's really good.
Very cool. My pick is an Ars Technica article entitled, "We Can Now Watch Grace Hopper's Famed 1982 Lecture on YouTube." It's by Jennifer Ouellette. So who's Grace Hopper? She was a rear admiral, a gifted mathematician, and a pioneer in computer programming. And this is a talk she gave, which is one of her best-known lectures delivered to National Security NSA, a National Security what? Association? No.
So it was looks like it was delivered
National Security Agency.
National Security Agency, and the title of the lecture was "Future Possibilities: Data, Hardware, Software, and People."
Yes. Apparently it's a great lecture, and they had to digitize it from some weird tapes. So now you can watch it. But who is she is very interesting. So she, got degrees in math and physics from Vassar, a PhD from Yale. She worked at Vassar as a professor. When World War II broke out, she enlisted, and she did a lot of computer programming. She was hired as a senior mathematician. And she had this idea that humans are easier to write English than to use symbols, right? Computers use symbols. So she said, I want to make a program, a compiler that will allow humans to write in English and compile it into symbols. And so that was the first compiler ever made, which is the basis for, programming today. You just write words and they're converted into symbols for the computer to use. And so that was her idea. And they say this led to the development of COBOL for data processors, which is still the major programming language used today. And the cool story also here is that in the presidential election in 1952, this computer UNIVAC was introduced by Walter Cronkite as the results from the presidential election were rolling in. Her team input voting information, but they also put information from earlier elections to try and predict the outcome. Remember, this was Adlai Stevenson running against Dwight Eisenhower. Mm-hmm. So all the press said Stevenson is going to win by a landslide, and UNIVAC, run by Grace, she said, no, Eisenhower is going to win. Our computer says based on previous results, and in fact, he won 55% of the popular vote, an electoral margin of 442 to 89, based on her and her team doing this analysis on this UNIVAC, an early big computer. So this is very cool. And so the lecture is great. You should listen to it because she's very animated and interesting. And
she was,
very smart.
From what I can tell here, when she gave the lecture, she was 75 years old.
Yep.
I'm excited to watch it.
Her wiki site has a great picture of her from 1984. which would have been, she would have been 77 in her Navy uniform and stuff. She was in the Navy for 43 years.
Cool.
Very cool. Grandma Cobol.
Great, great video. You should check it out.
All right, I will.
All right, that's TWiV 1147. You can find the show notes at microbe.tv/TWiV. You can send questions, comments, pics to TWiV@microbe.tv. And as I said earlier, if you enjoy these programs, please support us. We need your help. Microbe.tv/contribute. Rich Conda is an emeritus professor, University of Florida, Gainesville. He's currently in Austin, Texas. Thank you, Rich.
Sure enough. Always a good time.
And you were a colleague of Stephanie Karst, who was the senior author on that paper.
I chaired the search committee that hired her at the University of Florida.
There you go.
She's one of my all-time favorites.
Brianne Barker's at Drew University, BioProf Barker on Blue Sky. Thanks, Brianne.
Thanks. I learned a lot.
Yeah, a lot about bile acids, right?
Exactly.
I'm Vincent Racaniello. You can find me at microbe.tv. I'd like to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV, Ronald Jenkins for the music, and Jolene for the timestamps. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.